In the Ethiopian highlands, families are still eating from the same plants their ancestors planted hundreds of years ago. Not seeds, not fields, living food. There is a crop there that never needed replanting. You harvest it, and it grows back. You wait years, and it keeps storing food underground. One root system can feed a family for generations. It may be the most famine-resistant food crop humans ever domesticated. It does not grow in seasons. It does not fail all at once. It is not harvested on schedule. It waits. Modern agriculture replaced it with crops that die every year. Crops that can fail all at once. Crops that turn food into a gamble. This is enset, known locally as the false banana, and as climate systems destabilize worldwide, it forces a question we were never meant to forget. This is the story of the perennial food system we abandoned. Before agriculture meant planting and harvesting on schedule, food was something else entirely. It was not grown in cycles. It was maintained as a living reserve. Entire civilizations understood that the safest food was food, still rooted in the ground, alive and waiting. Drawn on demand rather than stored in silos vulnerable to rot, pests, and war. In the highlands of East Africa, families did not measure wealth by what they had harvested. They measured it by what still stood growing around their homes. A grove of perennial food plants was not a garden. It was a living savings account, an insurance policy written in roots and soil. You did not ask how much grain was in the storehouse. You asked how many plants could be cut tomorrow if drought struck, or guests arrived, or the rains failed for the third year in a row. This was the ancient logic of food security. Not surplus, not stockpiles. Living continuity. Food that breathed while you slept. And at the center of this system stood one plant that embodied the philosophy more completely than any other. In the Ethiopian highlands, above 2,000 meters, there grows a plant that looks like a banana, but is not. The leaves unfurl wide and green. The trunk rises thick and fibrous, but there is no fruit. The treasure is hidden below and within. A single enset plant, once established, produces offshoots called suckers. These suckers are separated and replanted, continuing the genetic line indefinitely. Families do not buy seeds. They do not save grain. They transplant from the same living stock their great-grandparents cultivated. One grove, tended across generations, becomes an unbroken thread of food security stretching back centuries. A mother plants, her daughter harvests, her granddaughter transplants again. The same root lineage, the same soil, the same quiet abundance. No annual gamble, no seasonal failure, no dependence on markets or weather or global supply chains. Just continuity. This is not farming as the modern world understands it. This is inheritance rooted in the earth. But how far back does this inheritance reach? The archaeological record traces enset cultivation back at least 5,000 years. In the Ethiopian highlands, stone tools used for processing the fibrous trunk have been recovered from sites dated to 3000 BCE. Linguistic analysis reveals that words for enset and its preparation exist in the oldest layers of Omotic and Cushitic languages, embedded so deeply that scholars believe the plant shaped the cultures rather than the other way around. This is not a crop that was adopted. It is a crop that built civilizations. Long before wheat spread from Mesopotamia, long before rice terraces carved into Asian hillsides, highland communities were managing perennial enset groves as their primary source of calories. They did not write their history in books. They wrote it in the continual tending of the same plants, generation after generation. The knowledge passed through hands, not texts. When Portuguese missionaries arrived in the 16th century, they recorded villages surrounded by dense enset groves, families eating from plants their ancestors had established centuries before. A food system older than European cathedrals, older than most written languages. And at its heart was a biology that made failure itself difficult. Enset is a perennial. Unlike maize or wheat, which complete their life cycle in a single season and die, enset lives for years. A single plant can grow for 5 to 12 years before it must be harvested. But even then, the system regenerates. Throughout its life, the mother plant produces suckers, genetically identical offshoots that emerge from the root base. Before harvest, farmers separate these suckers and transplant them into prepared beds. The cycle continues. No seeds are purchased. No planting calendar dictates survival. The edible portion is not a fruit or a grain. It is the starchy pseudostem and the underground corm, together yielding up to 40 kilograms of food from a single mature plant. This food can be processed into kocho, a fermented staple, or bula, a fine white starch. Both store for months without refrigeration when prepared correctly. The plant itself acts as living storage. It can remain in the ground unharvested for years, accumulating starch, waiting until the family needs it. No silo, no warehouse. Just roots holding energy in reserve, ready whenever hunger calls. A design perfected by evolution for exactly the kind of uncertainty humans face. Enset is called the tree against hunger, and the name is not poetry. It is engineering. In the highlands, where rainfall is erratic and drought cycles are measured in generations, enset provided a buffer that annual crops could not. When the rains failed, grain fields withered. But enset groves, deep-rooted and slow-growing, endured. A family with 30 mature plants could harvest a few each month, stretching their reserve across the worst years. The plant tolerates drought because it stores water in its massive pseudostem. It stabilizes steep hillsides, preventing the erosion that turns farmland into gullies. It grows in the shade of other trees, fitting into diverse agroforestry systems. And because it can be harvested at almost any stage of maturity, it offers flexibility no annual crop can match. Need food now? Harvest a younger plant for less yield. Can wait? Let it mature for maximum starch. This is not a crop optimized for maximum output in ideal conditions. This is a crop optimized for survival when conditions collapse. A living insurance policy against the inevitable failures of weather, war, and time. But then the world changed. The 20th century brought a new model of farming to the highlands. Colonial administrations and later development programs promoted annual grains, including wheat, maize, and teff for export. These crops fit a logic foreign to perennial systems. They demanded synchronized planting and harvesting, required purchased seeds, fertilizers, and pesticides, and produced yields that could be measured, taxed, and traded on global markets. Agriculture became seasonal, industrial, and extractive. The calendar replaced the grove. Instead of maintaining living reserves, farmers were taught to clear fields, plant in rows, and harvest everything at once. The surplus went to markets. The risk went to families. A failed season meant hunger. A failed season for enset farmers had meant harvesting earlier or deeper into the reserve. The perennial buffer was replaced by the annual gamble. Governments built silos, promoted storage programs, and shipped emergency grain when harvests failed. But the structural resilience was gone. Food security became dependent on logistics rather than biology. And in this new system, plants like enset didn't just stop making sense. They became a problem. When annual grains expanded across Africa, they did not just replace calories. They replaced a philosophy of food. Perennial systems like enset offered continuous harvest, household-scale management, and independence from external inputs. Annual systems demanded synchronization, mechanization, and market integration. Families that once ate from groves they controlled now depended on harvests that could fail completely in a single bad season. The shift was not driven by nutrition. Enset provides more calories per hectare than most cereals when land and labor are calculated over multiple years. It was driven by economics. Annual crops produce commodities. Commodities can be transported, stored, traded, and taxed. Perennial food plants consumed locally generate no export revenue and fit no ledger. Development programs measured success in tons of grain shipped, not in families fed from their own land. The metrics themselves were biased against resilience. What could not be counted did not count. And so the groves shrank. Young people left for cities. The knowledge of processing, transplanting, and managing enset began to fade. A 3,000-year-old system started collapsing in a single generation. Not because it failed, but because it could not be commodified. Enset resists every feature of industrial agriculture. It matures slowly, requiring 5 to 12 years before optimal harvest. It cannot be harvested by machine. The pseudostem must be scraped by hand, the fibers separated, the starch fermented for weeks or months. The final product, kocho, is heavy, moist, and does not transport well. It spoils faster than dried grain. It has no global market, no commodity exchange, no futures contract. You cannot ship enset across oceans. You cannot warehouse it for years. You cannot patent its genetics when farmers have been propagating it through cuttings for millennia. Every feature that makes enset valuable locally makes it worthless globally. Resilience does not price well. Household independence generates no revenue stream. A plant that feeds families without requiring annual purchases is a dead end for agribusiness. And so an enset remained invisible to international agricultural research for decades. Funding flowed to wheat, rice, and maize, crops that needed improvement, inputs, and infrastructure. Crops that created dependencies. Enset asked for nothing but knowledge, and knowledge was not what the 20th century was selling, but the 21st century is asking different questions. Climate models now project that large portions of the tropics will become unsuitable for maize and wheat within decades. Rainfall will become more erratic. Droughts will lengthen. The annual crops that replaced perennial systems are failing exactly the way perennial systems were designed to survive. In 2021, researchers published the first complete genome sequence of enset. The study, led by scientists in the United Kingdom and Ethiopia, revealed genetic pathways for drought tolerance, disease resistance, and starch accumulation. For the first time, international science acknowledged what highland farmers knew for millennia. This plant was engineered by evolution for instability. Modeling studies suggest enset could potentially be cultivated across a much wider range of African climates than previously understood, offering food security to over 100 million additional people. Development organizations are beginning to fund enset research. Agronomists are documenting traditional processing techniques before they disappear. The same institutions that ignored the plant for a century are now racing to understand it. Not because they finally respect indigenous knowledge, but because they are running out of options. The climate is closing doors. Enset is one of the few still open. Enset was never a crop in the modern sense. It was a relationship, a living agreement between people and plant, stretched across generations. You did not plant enset to harvest it. You planted it to have it, to maintain it, to draw from it slowly across years and decades. The grove was not a field to be cleared. It was a presence to be sustained. Modern agriculture cannot comprehend this. It sees only inputs and outputs, costs and yields, seasons and shipments. But the oldest food systems understood something different. Security is not a stockpile. Security is continuity. It is roots still drawing water while the rains fail. It is a mother transplanting suckers her grandmother transplanted before her. It is food that waits. We did not lose enset because it stopped working. We lost it because we stopped understanding what it was. A food that was never meant to be harvested all at once. A system that asked only to be continued. The knowledge still lives in the highlands, in the hands of farmers who never stopped tending the groves. The question is whether the rest of the world will remember in time.